Yo, what's up everyone? Today, we're diving into something super dope. The theory of everything and quantum computers. Dr. Michio Kaku, a big-shot physicist from the City University of New York, is taking us on a wild ride through science. Kaku got hooked on physics when he was just 8 years old. Picture this. A kid hears that Einstein left an unfinished manuscript about the theory of everything on his desk. What's the theory of everything? A tiny equation, maybe an inch long, that could explain all the secrets of the universe. Kaku says it's like reading the mind of God. When he heard about it, he was like, I gotta figure this out. Now, Kaku's one of the brains behind string field theory, an idea that might just crack this legendary equation. And guess what? Quantum computers might be the key to solving this puzzle. Bottom line, physics isn't just some boring class. It's about stars, galaxies, and black holes. All right, let's talk about something totally rad. Quantum computers. These aren't your regular computers running on zeros and ones. Quantum computers work with atoms and can crunch numbers in parallel universes. Kaku says they're so powerful that digital computers look like abacuses next to them. Think about it. They could totally flip the economy, medicine, and even food production. Like in farming, they could help us make new fertilizers from nitrogen in the air. Or in energy, they could unlock fusion power using seawater as fuel. In medicine, they can model diseases like cancer or Alzheimer's at the molecular level. But here's the catch. These things are so strong, they could crack any digital code. That's why the FBI and CIA are all over this. Why is this such a big deal? Because Moore's law is running out of steam. Transistors can't get much smaller or they'll short-circuit everything. That's why big players like Google and IBM are racing to build the first quantum computer. If you're not in this game, you're basically left behind in the future. Now, let's get into something totally wild. The theory of everything. This is an equation that could explain all the rules of the universe, from gravity to tiny particles. Kaku says string theory is our best shot at cracking this equation. Imagine all subatomic particles, like electrons and protons, are just vibrations of tiny strings in a weird place called hyperspace. Kaku says the universe is like a symphony of these strings, and the mind of God is cosmic music. This theory is super cool because it covers both Einstein's gravity and subatomic particles. But its rivals, like looped quantum gravity, only focus on gravity and skip the particles. To be a theory of everything, it's got to check 3 boxes. First, it's got to fully explain Einstein's gravity. Second, it's got to say why we have so many subatomic particles. Third, it's got to be mathematically solid, no weird glitches. But here's the thing. String theory predicts particles we haven't seen yet, like dark matter. To solve these crazy equations, we're gonna need quantum computers. Kaku says this theory's so out there, it might just be right, because all the simple ideas have already been tried and failed.
There's this old question people have always wondered. Is the world just a dream? The modern version is the universe a computer game? Like in The Matrix, where everything's just a simulation. Kaku says it's super unlikely because simulating the whole universe is basically impossible. Imagine trying to simulate the movement of trillions of atoms in just one room. No computer's powerful enough to pull that off. Thanks to the quantum principle, atoms are always moving, and you can't pin down exactly where they are. There's also this thing called the butterfly effect. One flap of a butterfly's wings could spark a storm. To simulate even a fishbowl, you'd need a number with 25 zeros worth of info. Bottom line, Kaku's like, sorry, we're not living in a simulation. But where'd this idea, so hot in Hollywood, come from? From quantum theory and string theory. Movies like Everything Everywhere All at Once got inspired by these scientific ideas. Let's talk about something crazy exciting: intelligent life in space. Kaku says if aliens exist, their intelligence might be totally different from ours. Like, dolphins have their own language, and computers can analyze it to show they're smart. But their smarts are different from ours, like how the letter E is super common in English. Kaku breaks down alien civilizations into 3 types. Type 0, like us, still using oil and coal. Type 1 is planetary. They can control weather and earthquakes. Type 2 is stellar, like the Federation in Star Trek, using the sun's energy. Type 3 is galactic, like the Empire in Star Wars, messing around with black holes. We're still Type 0, and it might take 100,000 years to hit Type 3. What about UFOs? The US Navy says they've got tons of weird videos. Objects flying at 20 Mach, diving underwater and zigzagging like crazy. These things break our engineering rules. No living thing could survive that acceleration. 90% of these sightings can be explained by stuff like balloons, but 10% are still a mystery. Kaku says we gotta analyze this data frame by frame to figure out what's going on. Now the military's gotta prove these aren't aliens because public pressure is doing its thing. Let's take a trip through the history of computers. Back in the day, people used analog stuff like sticks and gears to count their cows and crops. Then Charles Babbage built this dope analog machine that could calculate bank interest and ship coordinates. But during World War II, that wasn't enough to crack German codes. Enter Alan Turing, who laid the groundwork for digital computers with his Turing machine. Every computer we've got today is basically a Turing machine, running on zeros and ones. Turing even came up with a test for AI called the Turing test. You put a robot and a human in boxes and ask questions to figure out who's who. So far, no robots fully passed this test. Sadly, Turing was persecuted for being gay and probably took his own life. Some say Apple's logo, that bitten apple, is a nod to him because he died with a poisoned apple. Then came Richard Feynman, a genius physicist who dreamed up quantum computers. He said transistors would one day shrink to the size of atoms and use quantum principles. These things don't just use zeros and ones, they calculate with everything in between. Picture a mouse in a maze. A digital computer checks every path one by one. But a quantum computer checks all paths at once, like it's infinitely faster. That's the power of quantum computers that could totally change the future of science.
All right, that was an epic journey through science with Dr. Michio Kaku. From the theory of everything that could unlock the universe's secrets to quantum computers that'll reshape the future. String theories like a cosmic symphony, tying it all together. A simulated universe? Nah, probably not, but the idea comes from physics. Alien life might be way more advanced than us, and UFOs are still a big mystery. From old-school abacuses to AI and quantum computers, science is taking us to wild places. Kaku says the universe is full of harmony and secrets, and maybe one day we'll read the mind of God with this tech. Thanks for watching. Drop your thoughts in the comments and share this video with your crew.